We're looking at example 6 found in your pre-calculus part 1 textbook. This is in lesson P-7, found on page 89. In this particular example, we are going to solve an absolute value equation. Now, in order to do that, first of all, you've got to isolate or to get the absolute value by itself. So if you'll notice, the absolute value is being multiplied by 5 as well as 15 is being subtracted from it. So I need to fix some of these because we need to get just the absolute value part by itself. So step 1 is you have to add the 15 over, which is what gives you this step down here. Okay. Then step 2 would be I'm going to divide both sides by 5. When I do, it will eliminate the 5 on the left side and just become a 3 on the left side. So I have the absolute value of 1 minus 4x equals 3. Now here's the unique thing about an absolute value. Anything inside an absolute value could be positive or negative, because remember, the whole concept of absolute value says it turns negative numbers to positive, as well as if it's positive, it just keeps it positive. So what we're trying to say here is, and the reason they've come up with two equations, this equation here and this equation here, is because 1 minus 4x, what's inside that absolute value, could be 3, or it could be negative 3. We don't really know. All we know is overall, because the absolute value is around it, it's equal to 3. But what's inside of that, the actual 1 minus 4x, could be positive 3 or it could be negative 3. Because of the absolute value sign there. So that's what we do. We take the two, we split the equation up, and we write it equal to 3, and then we write it equal to negative 3, like it's two separate equations. Now, on the first one, we're going to subtract a 1 over to the other side, and by doing so, we get negative 4x equals 2. Then you would divide both sides by negative 4, and 2 over negative 4 becomes this answer right here, or x equals negative 1/2. The second one, by setting the minus, or 1 minus 4x equal to negative 3, again, if I subtract 1, this time I get negative 4x equals negative 4. When I divide both sides by negative 4 here, I end up with x equals 1. Okay? So I end up with two different answers. Now, we're not going to take the time, but you should always kind of, if you want to check yourself and make sure that they're correct, put in the two numbers that you were given back into the equation and see if it makes the equation true. It has been checked. You get a true statement, 0 equals 0 on this one. So that means that negative 1/2 and 1 are the solution set to this particular problem. Okay, so let's do another one. Look at checkpoint 6 here. Again, we're going to work it the same way. I'm going to add 20 to both sides first, because remember, I'm trying to get the absolute value by itself. 1 minus 2x equals, and now the positive 20 is over on the right side of the equal. Second step is we're going to divide both sides by 4. By doing so, I'm going to be left with 1 minus 2x, and 20 divided by 4 becomes 5. Now, remember, like I said before, when that's an absolute value, I don't know if it's equal to 5. I don't know if 1 minus 2x is equal to 5, or if 1 minus 2x is equal to negative 5. So I have to be able to work it both ways so that I can see both answers. So I'm going to subtract 1 from both sides. That's going to leave me with negative 2x equals 4. Divide both sides by negative 2, and x becomes negative 2 as one of my solutions. If I do it the other way, if I subtract 1 in this problem, I get that negative 2x equals negative 6. Divide both sides by negative 2, and x becomes positive 3. Okay. Now, again, if you were to check those, and I did previously, you would plug the negative 2 in there and see if it ends up being true, and then you would also plug the negative 3, or positive 3 in there and see if that's true. Both of them, again, actually work. So I would write my set notation, I would write -2, 3, because both of the solutions work, and that would become my answer. Hope this was helpful.